Hey guys, this video is part 2 of using control programming for VEX code V5 or the V5 VEX system. If you haven't watched part 1, I programmed the drivetrain. In this part, I will be basically programming anything else. So that may be an intake, a claw, a lift, any other mechanism essentially that doesn't use joysticks to control. Okay, so first we have to open up our system. So VEX code v5, I already have it open here. If you don't know how to open it, click the spotlight key and search up VEX code v5. While it opens, we want to reopen our file. So make sure you remember where you saved that. That's why it's so important. I have it saved. It defaults to open wherever you last opened a file. So it's right here. Nice and safe. I like to just close out these tabs to give me more room to code and visualize things. As it's pretty kind of room consuming to do so to have open. So if we did on the last part is program our drive for our left side, right side, now we have our lift to do. In this example, I'm going to be using a theoretical lift because I don't actually have a robot to program in my house. I recorded a series of VEX IQ videos with an actual VEX IQ robot where I demonstrated how to work it, work the example and stuff. But Lyft essentially provides all of our examples because it shows us how to open, go in one direction, go in another direction, etc. So first thing we want to do is define our lift motor. Just gonna do a simple lift. If you need to change the gear cartridge, feel free to do so. If you need to reverse it, feel free to do so. This example, not doing anything super complicated, just to give you the general idea of how it would work. Actually, I need this tab back open to show you guys this. So in this video, the purpose, I always like to define my purpose in the beginning before programming, just to have an idea of what we're supposed to do to kind of give an outline at the beginning. So in this video, I'm going to have R1 go up and move my lift up, and then R2 move my lift down. So that's what I want to do. Basically define what actions you want to happen. So in this example, we're going to have to use something called if else, if else, if else, okay? If you have some prior programming experience, you'll already know what this is, but essentially the best way that I can explain it is that I'm going to just kind of do an outline and I'll explain how it works. So first we want to check if one button is being pressed. If that isn't happening, then if another button is being pressed, we'll do whatever happens in that block of code. But if none of those conditions are met, then it's going to do something else. So I don't know why I keep closing this tab because I keep referring back to it. But let's say if R1 is being pressed. So the way that you would call that is actually pretty similar to how you'd call this kind of section of code that we did in the last part. If controller 1, because we're referring to something that's related to, button R1 is the name, because we have a nice little handy thing right here, is pressing. By the way, press and pressing are different things in VEX. Then it'll run whatever's in this these two brackets. If that doesn't apply and R2 is being pressed, then it'll run whatever's in these brackets. And if none of these prior conditions are being met, then it'll run whatever in these brackets. So essentially, let's say R1 is being pressed, right? That means that we want to have something to happen within our code, aka we want our lift to move up. Let's say forwards is up and then reverse is down. If it's not, then you can just go in your initialization tab and then reverse it, and then it will apply. We're going to use the exact same line of code here, but instead of getting this axis 3 position stuff or axis 2 position, we'll just set it to a defined amount because a button, you can't get the position of a button. A button is pressed or not pressed. That's the only data you can collect. And so what we're going to do is have it set a certain speed based on that. So that will be lift dot spin forward. Say an 80% is a good starting point if you built a solid lift. And then we want to do the opposite. We want it to go reverse when it's not being pressed. So we also want 80% here. Now in the last part, if nothing is being pressed, we want the lift to stop. So what we're going to do is use our dot stop function with our lift motor. And we can actually tell it the brake type. There's 3 different kinds of brake types in VEX. There's coast, which means that it'll stop the motor, and whatever it continues moving forward, it'll keep going. There's brake, which is what I'm using in this video, which means it'll stop, have it stop exactly at that point as much as it possibly can, but if some other force is pushing up against the lift per se, it won't do any effort to kind of continue stopping that. And this is good for many instances because it'll kind of allow you to keep that consistent stopping point, but it won't use extra resources afterwards to maintain like the position of it, because at that point you can just redo it, because hold takes up a lot, like having it continuously checked, like putting force to make sure it doesn't move, takes up a lot of extra energy on your robot. And that brings up to my third type of brake type, hold, which means it'll stop it and it'll keep it stopped. AKA if something else pushes up against it, it'll put force back into stopping it, which takes up a lot of resources. But if you want something super strong, like something to like let's say you want to lift up your entire robot by hanging it off of a tube, then it's reasonable to put hold on something like that. Or you want something to have extra grip on something that you're trying to grab, maybe that's reasonable. But for my scenario, we're just gonna go with brake. Use what's applicable to you. So now essentially this is all of our code. Now you can use the same exact code for something like a claw. All you have to do is change the buttons and then change the motor that you're calling, and it's your claw. Another situation that you can do is get another set of 2 buttons, and then maybe you want it to go significantly slower. Let's say you want R1 and R2 to be for your lift to move fast, but then you want L1 and L2 to be for your lift to move slower. Same thing, just change the buttons, change the speed. That's how you get that done. If you want an intake, same code. So you want your intake, let's say the purpose of your intake is this button outtakes, this button intakes. Well, you just set the button, which is button up. That button's up, left, down, and right, and these are just X, Y, B, A. Just do the same thing, works the exact same way. There's many ways you can use this exact same code for user control. This is just one very basic example. But yeah, if you have something like let's say you have a 2-motor lift, then you'd write the 2 lines. Like let's say it's gonna give me an error, but whatever. Spin forward 80%. There, you got 2 lifts running under the same button now, because remember, whatever is in the brackets is what's going to run. You just have to copy the same exact line of code and reverse it down here so that it also stops, and then you have an equivalent line of code to stop when it's not running. Because the reason why you need this line of code at the bottom is because if you don't, it'll continue running forever. It doesn't know when to stop spinning, so that's why it's important to define this else. Okay, if nothing is being pressed, we just want it to be stopped. That's it. That is all the code for your user control part 2. If you have any questions, feel free to reach out. And yeah, hopefully this video helped you guys out.